This week, there are 4 different topics that will be dealt with by means of 4 different videos. All these topics are relatively smaller as compared to the topics that we've been dealing with before. However, they do require a certain level of understanding. So I'm not going to publish more material this week, so it might seem less, but actually you already have enough on your plate with the assignment and the homework. So make sure you are following everything along with these extra videos for this week. We are going to look at higher order elements. I have been talking about these higher order elements since the first lecture, where I first introduced the truss elements, or just 1 degree of freedom at every node. And then I went on to say that these are linear elements. And then for beam elements, which are also one-dimensional elements, we took care of an approximation function of quadratic order. So as you can see, we have continuously been playing with different kinds of order or different kinds of approximation function. And in this particular video about the higher order elements, we will discuss about higher approximation order that we'll pick up for certain elements and what is its advantage and shortcomings, etc. in terms of finite element analysis. We will also see how the higher order elements with the higher approximation order contribute towards convergence. Then in another video, I will introduce you to something called the Lagrange polynomials. Lagrange polynomials is a simple tool which is going to help you set up shape functions quite easily. Now in general, so far with the simple elements that we have dealt with, the shape function formulation was very simple. We started with the displacement approximate function. We put in the boundary conditions, we solved for the unknowns, and in the end we had the different shape functions for the number of degrees of freedom in the system. Now if I keep increasing the approximation order, then it would become more and more difficult for us to find the shape functions because there will be so many. And therefore we would have to have a large system of equations to be solved. So instead of going into such a complicated way of making shape functions, we can also formulate it just by means of combination of linear functions. And this is what I will show you in the Lagrange polynomials. Then we will move on to natural coordinates. Natural coordinates is also just another representation of the coordinate system that we are used to using. It easily links us into isoparametric elements. Isoparametric elements in general are a representation of a simple element that you are already aware of. Isoparametric elements we will go to when we study 2D. But it's good to already know what an isoparametric element is. So this week in the video, I will only just barely introduce you to an isoparametric element, and to do so, we need to understand what natural coordinates are, because isoparametric elements are actually described by using the natural coordinate system. So let's get on with individual videos on 4 topics.